Students, this is Mr. Allen, and today we are going to continue our journey through Chapter 2, which is on deductive reasoning and proof, and we're going to look at something called conditional statements. 2.2. The objectives here today are for students to recognize conditional statements in their parts, and students will be able to write converses, inverses, and contrapositives. So our first key idea here is what is a conditional statement? And a conditional statement is just a statement that is written in if-then form. So that is what a conditional statement is. So for example, if P then Q, or P implies Q, is called a conditional statement. Here's an actual example. If it rains, then it pours. That's kind of a classic if-then statement. Symbolically, we would just write that P arrow Q. If P, then Q. The P part is called the hypothesis. This is the hypothesis. And the Q part is called the conclusion. P is the hypothesis and Q is the conclusion. In order for a conditional statement to be true, P must be true, and then Q will be true. So for example, what are the hypothesis and the conclusion for the following conditional statement? If an animal is a robin, then the animal is a bird. So remember, P arrow Q, the P is the hypothesis, and the Q is the conclusion. So the hypothesis here is an animal is a robin, and then the then part is the conclusion. So our conclusion here is the animal is a bird. So the hypothesis is the animal is a robin, the conclusion part, then the animal is a bird. So how can we write the following statement as a conditional? So here you see a statement, vertical angles share a vertex. It doesn't appear to be in P arrow Q form. It doesn't appear to have an if and then a then. But we can change that. So what would the hypothesis be and what would the conclusion be? Well, I think, let's go ahead and erase that. I think the hypothesis part is the fact that they are vertical angles. And then the conclusion part would be that they share a vertex. So for example, angle ABE, this angle here, and angle CBD, this angle here, those are vertical angles and they share a vertex. So if they're vertical, I just said it, if they are vertical angles, then they share a vertex. So again, here is our hypothesis. They are vertical angles. Sorry about the poor handwriting. Then they share a vertex. That's the conclusion. So I've taken a statement that's not in if-then form and I've written it in if-then form. Okay, so I'm going to need to move my video here a little bit for this one because this slide we're going to talk about something called a truth value. It says if a conditional statement, is the conditional statement true or false? If false, find a counterexample. So a truth value is just true or false. So if a shape is a triangle, then it has three sides. Well, I would say that that statement is true because that's how we actually define a triangle. A triangle is a shape with three sides. So that's just true. Let's see if the second one's true or false. If a number is divisible by 5, then it's odd. Okay, so the hypothesis here is that it has to be divisible by 5. So numbers that are divisible by 5 are numbers like 5 10, 15, 20, 25. Oops. Out of room here. Sorry, guys. There we go. 25. Okay. And so we want to know if a number is divisible by 5. These are all divisible by 5. Then it has to be odd. Let's see here. Well, that number is divisible by 5, but it's not odd. Heck, this one here is also divisible by 5, but not odd. So this one's false. This is false. So now we just need to provide a counterexample for why it's false. So a counterexample, remember, is just a statement that shows that a statement is not true. So the counterexample I would use here would be 10. 10 is a number that is divisible by 5, but not odd. Okay, so now we're going to talk about different forms that a conditional statement can be written in. So if I have the true conditional statement P arrow Q, like this right here, we have something called the converse. The converse, you take the hypothesis and the conclusion and you switch their order around. In other words, you put the conclusion first and the hypothesis second. So for example, if we had, look at these examples right here. If I said a conditional statement is, if angle A is 15, then angle A is acute, which is a true statement. What would the converse of that be? Well, we're going to take the P and the Q and we're going to switch those around, which is the following. If A is an acute angle, then the measure of angle A is 15. So notice that P arrow Q became Q arrow P. Next up, let's consider the inverse of a conditional statement. So remember, our base case is P arrow Q. The inverse, instead of switching them around, we're going to do something called negate. Negate is just a fancy word for not, or do the opposite. Okay, so if I wrote negative, same thing. So what would be the opposite of he is rich? Well, the negation would be he is not rich. What is the negation of the team wins? The team did not win, which you could also say that they lose or something like that. So if I'm going to do the inverse of P arrow Q, then it's going to be written like this. Tilde P arrow tilde Q. Notice that P and Q did not get switched around in order, but we negate them. So our original statement was, if the measure of angle A is 15, then angle A is acute. The inverse of that would be, if the measure of angle A is not 15, then angle A is not acute. And last but not least, we have something called the contrapositive. Again, remember, we're starting with our base conditional P arrow Q. Here we are going to converse them, but we're also going to negate them. So we take the P and the Q and we switch them around and we negate them. So remember, our original hypothesis or our original conditional statement was, if the measure of angle A is 15, then angle A is acute. The contrapositive would be, if angle A is not acute, then the measure of angle A is not 15. So we took the Q and the P, we switch their order, and we negate them. So this is just a nice little summary table of what we said. So if we have a conditional statement, P arrow Q, oops, sorry about that. I wanted to use yellow. P arrow Q, if P then Q. The converse would be Q arrow P, switching the P and the Q. The inverse is the negation of the hypothesis implies the negation of the conditional. So there we did not switch P and Q, but we negated them. And then the contrapositive, this is where we switch their order and we negate them. Not Q implies not P. Okay, so now this example here, I'm not going to write these by hand. I've already typed these in to kind of speed the process up. It says write the converse, inverse, and contrapositive of the following statement. It says if it's a square, then it has 4 right angles. Would you guys agree that if it's a square, it has 4 right angles? So what would the converse of this statement be? The converse. So remember, the converse, you take the P and the Q and you switch the order. So we need to switch the hypothesis, which is this. This is the hypothesis, and the conclusion. We're going to switch those around. So the converse would be if it has 4 right angles, then it's a square. I left a word out there. So notice that 4 right angles now is at the front, and it's a square is now in the back. What about the inverse? Now in the inverse, remember, we don't switch the order, we just negate them. So we want to negate the hypothesis if it's not a square, and then we want to negate the conclusion. Then it doesn't have 4 right angles. And last but not least is the contrapositive. Remember, on the contrapositive, we switch the order and we negate. So we're going to take it's a square part, we're going to put it at the end and negate it. And we're going to take the 4 right angles, put that in the front, and negate those. If it does not have 4 right angles, then it is not a square. So this is a really important slide. I think that it does a nice job of illustrating. Of course, I have a little grammar issue here, but converse, inverse, and contrapositive. Now, example 5, this is our last example. It says determine the truth value for each of these statements. So now we're just going to determine which ones were true or false. Now, and by the way, we would agree that originally this initial conditional statement was true, right? If it's a square, it has 4 right angles. So how about the converse? If it has 4 right angles, then it's a square. Well, I would say that that's false. And the reason I would say that is false is consider a rectangle, okay? A rectangle has 4 right angles, but it is not a square. That's a counterexample. How about inverse? If it is not a square, then it does not have 4 right angles. Well, I'm going to say that's false as well. For the exact same reason, oops, can't spell here today. I'm going to say that's false as well. Again, I'm going to give you a rectangle. A rectangle is not a square, but it does have 4 right angles. So that's another counterexample. So both the converse and the inverse are false. So what about the contrapositive? What do you think that one's going to be, true or false? If it does not have 4 right angles, then it's not a square. Well, it can't have 4 right angles. And guess what all squares have? 4 right angles. So this one actually has to be, this one is true. This one is true. And it turns out that the contrapositive, I should probably add this note, the contrapositive, if the initial conditional statement is true, the contrapositive will also be true. If the initial conditional statement is true, the contrapositive will always be true as well. Now, these other two, the converse and the inverse, they may or may not be true. In this case, we saw that they were both false. I think that will end it. Have a great day.